Hey everyone, this is Mayur. Welcome back to ML Works. In the previous video of system design, we were discussing about single server setup and database and scaling, which is horizontal and vertical scaling. So in this video, going forward with the system design videos, right? So we'll be talking about load balancer and data replication, which is database replication. And with that, we'll understand how to scale the system of your choice. Okay. So load balancer is one of the component in system design where you what when you have a request load coming in, okay, and you want to route the traffic to the servers, right? Load balancer comes into picture at that point in time. And what it does, right? So it distributes the load of the incoming traffic to the multiple servers in a load balanced way, such that not one of the server is overloaded. So to avoid that, we distribute the load. Now the servers, right, are not directly what reachable by the user, which is the browser or a mobile app. So you have to hit the load balancer through its public IP address, and then the load balancer will reach out to the web server and fetches the result for your request. Now, as I as can be seen from the diagram, right? So the browser will hit the IP the website. It will fetch the IP address from the DNS. Now this IP address is nothing but the public IP address of the load balancer. Now with this IP address, when you hit, it uses the browser or the mobile app uses HTTP protocol to hit the IP address of the load balancer. Then it goes to the private IP address of the servers. Now, the server will have its own network, okay? It will have its own virtual private network and they can communicate with each other, okay? The servers can communicate with each other. Now, let's understand that part, right? Load balancer can access the private IP associated with the web server and the web servers can communicate with each other using the private network. Now, when you have such a setup, right, where you have multiple servers, whenever the server goes down, okay, the automatically the request from that's which is assigned to that particular server, it will be moved towards server 2. Okay, so that is one of the way to handle what single point of failure. Okay, so that is one thing. And also, if the two servers are not what able to handle the load, what we can do is we can add more servers to the your web server pool, and then you can route the request to those web server as well. Okay, this is with respect to load balancer. Okay, so when you have a lot of load coming to your web server, then you can add more web servers to your cluster, and then you can handle the request, and you can route the traffic based on certain algorithms. Okay, consistent hashing, and those are some different algorithms that can be used in load balancer, which will help you to route the traffic. Now, what about the database, right? So there will be like lots of requests coming in, write request, read request coming to the database. And if the database goes down, automatically you won't be having access to the data and you won't be able to load anything for the user. So what you can do is you can do something called as database replication. It is one of the way to avoid losing data and also having higher availability for your data, right? So that can be achieved through database replication. So database replication follows something called as master slave architecture, which you mean by there will be one master and there will be multiple slaves. And the multiple slaves in this sense, there will be multiple copies of the same database. Okay, what I mean by that? So here master is the primary database which takes the write request and all the modifying request like update, delete or any other form of request, right, which requires some modification are sent to the uh, master DB. Okay, all those modifying requests. But only the slave takes in only read request. If you have like tons of read requests coming from the end user, for example, if you have Facebook, okay, the write will happen only once. Like not many people will write a post or not many people will create an account at the same time. Okay, all these will be taking place very rarely. Okay, the write request. And also when it comes to read request, okay, you have to pull the data. Okay, you see, and when you see the Facebook page, okay, you have news feed, so you have to pull the lot of data from the database, so you have to do read request a lot of times. So that's why what will happen is in a master slave architecture, you will have a master DB and you have multiple copies of the master DB in the form of slave DB. Okay, where the all the write request that is coming from the user, it will be pushed to directly to the master DB, and in a certain amount of time it will replicate those data, updated data, to the slave DB. Okay, and whenever the request comes, like a read request comes in from the user, then it will be pushed to slave db and it will pull the data from slave db. But whenever a write request comes in or update request comes in from the user, it has to be pushed to the master db, because there will be less number of read there will be less number of write request, and update request will be less number of times, so it will be pushed to master db, and all the read requests will be moving to slave db. So one thing, right? Most applications have, yeah, as I said, most applications have more reads over writes, thus resulting in more slave DBs than master DB. Okay, with that, what we'll understand is the performance aspect of this architecture, right? So when you have master slave architecture, so you will have like all these parallel requests will be happening at the same time. Read will be happening on the slave DB and the write request will be happening on the master DB, which will be what resulting in a better performance, because you don't have to access the same DB for all kind of actions. And then comes the, if a master DB goes down, okay, which is only one copy is present, so there will be slave DB with the data present, and it will be acting as a promoted as a master DB. Okay, out of consider there is this master DB and this goes down, there are three slave DB and one of them will be picked as master DB. And once the master DB is what, if that, then this particular slave DB, right, will be replaced, and it will be replaced with the another slave DB. Okay, so with that, this is for one master DB. And also, so this results in a reliability. Okay, when it comes to what the concept of reliability, this comes into picture. Okay, the multiple slaves will be acting as, one of the slave will be acting as a master DB when a master DB goes down. And consider if a slave DB goes down, okay, then the, if slave DB 1 goes down, the request will be sent, read request will be sent to either 2 and 3. Okay, this is one way of what, this is one of the architecture where you have single master and multiple slaves. There are cases, okay, where you have one master and one slave. Okay, if a master goes down, in that case your slave will become master. Now if the slave goes down, the all the read request will be sent to master DB until the slave DB comes up again. Okay, that is another scenario. And in production setting, what happens is, there will be multiple masters and multiple slaves. So even if the master goes down, the master will be present, the other master will be present to take over. So that is how the architecture is built normally in production settings. So let's understand this diagram as well, right? So you have DNS, okay, and you have your mobile app. You are hitting site.com, you're getting the IP address from the DNS, and that particular IP address belongs to the load balancer's public IP, and the web app hits the public IP of the load balancer, and the load balancer hits the private IP of the web server. Now that web server will be accessing the DB based on the kind of request it is. It will be sent to either a slave DB or either it will be sent to the master DB. Okay, that's the whole flow of this particular database replication along with the web server looks like. So web server part is called as web tier, which can be scaled separately, and data tier is separately can be scaled again independently from the web server part. Okay, so this is what with respect to what database and the replication is and what is load balancer is. Okay, so with that I'll be concluding this video. Thank you so much.